Here we go. Tonight we're covering Chapter 6 about files. Now, when we're talking about files here, we're talking about human readable files, text files as they are known. Files that you can open up with Windows Notepad and you can easily read them. Unlike certain other files that you open up and you get a bunch of weird characters and so on that are not human readable, those are called binary files. Well, we're only going to be looking at text files here. And text files are very good for, what do we use them for? Anybody? What do we use files for?
Kind
of a tough question.
Inventory, databases.
That's right. To store things, right? To store information. Yeah. Basically, the basic function of a file is to store information so that you can access it at a later date. It's all about saving and retrieving. And that just lets you know right there what the two parts of this chapter are all about. The first thing we have to learn is how to create a file by writing information to the file or writing data to a file, and then how to read that file after we've written data to it. So those are the two main functions. And right off the top, I just want to make one very important point. All file input and output uses strings. As you know, we've got ints and floats and strings in Python. Well, when you're reading a file, and this is true in any programming language with a text file, because a text file, text means string, you see. And so text files, you're always reading strings or writing strings. So all of your input and output uses strings. So as a first example, I've got a couple of files to try with you today, and want to take a look at one here that I've called MakePals, and I'm going to pop it on the screen here. Here's what it looks like. Take a look at this file here. What we're going to do is save some names that we enter from the keyboard into a file. And we're going to create a file called pals.txt to store the names of our pals. Well, in order to do that, we have to use the open function. The open function in Python allows you to connect with the file in a particular mode. And in this case, the file is going to be called pals.txt. By using that .txt file name extension, we can easily open it with our text editor. And we're going to open that file in W, which means write mode. So notice both of those are strings. So pals.txt in mode W. But we have to then hook that up to a file object, which I'm going to call it my file. You could use any name at all here. I've chosen my file. We could call it file. We could even just say F, or we could say pals. It wouldn't matter. Anything at all. That's a file object. So there's actually quite a bit going on here, and I've tried to explain it with the comment. Basically, what this line does is open a file called pals.txt in write mode and hook it up with an object called myFile. And it's the object myFile that we're going to use to write information to the file. Now, let's say that we're unsure of how many friends' names, how many pals that we're going to enter. So what we'll do is we're going to use a priming read. We're going to ask the user to enter the name of a friend. And we'll store that in a variable pal. And then we'll use a while loop that will continue to execute as long as pal is not an empty string. You see, notice here we've got or enter to quit. So if we are entering a pal and we just press enter, that makes it the value of pal an empty string. And that would stop this loop from running. But as long as we enter a name for our pal, this loop will continue the cycle. And what are we going to do inside that loop? Well, we're going to write the file using the write function that's in the file object. My object called myFile has a function called write that has been programmed into it by Guido and his friends. And what we're going to write is the pal variable And we want to put it on its own line in the file. So we'll append to that a \n, which causes a new line, as you know. Now, we repeat this line here exactly inside the loop. That's called the continuation read. So you start off with the priming read, which is necessary to get the loop started. And then inside the loop, you continue with the continuation read, which is exactly the same as the priming read. And that should continue to cycle as long as we enter names. So let's give it a try here. We'll give it a run, F5 function key. And I'm gonna, got some names that we can try that I usually like to use. I'm gonna go with Penny, Lenny, Jenny, Danny, and Kenny. Now let's say that's it, that's all we want. So if I press enter, that stops the loop. Okay, the loop is stopped, the file was created. Let's take a look at that. We should have something on the disk though, that my computer disk. I'll open it up here so you can take a look at it. There's the file. As you can see, it is a human readable text file, which has the names that we entered, and it ends up with a blank line at the end. That's important. Notice we got a blank at the end here. Okay. So that's the file. That's how easy it is to create a file. And this technique of using the while loop and the priming read and the continuation read is the best way to deal with a file when you don't know exactly how many you're going to enter, how many names we're going to enter. I could add another name right now. If I were to run this again, though, if I were to start this over again in W or write mode, what that would do is it would overwrite the file. It would overwrite it, erase it, and it would start making a new file called pals.txt. Well, I wanted to show you this other mode called A for append. If I put an A here, that puts it into append mode. Okay, and I just want to run this one more time. And here it is running. And this time I'm going to try Danny and Manny. And maybe that's all I want. So I'll press enter to quit again. Let's see what's in the file. If I open up the pals.txt file again, you can see that they've been added. The append mode adds on to the end of the file. If I'd left it in W mode, it would have overwritten the file completely, and I would only have Danny and Manny in the file. Everybody okay with that? Any questions about that? Any questions about that one? Welcome, Angelo. Any question about that one? No? Everything good there? Okay. All right, well, keep that file in mind, okay? What we've got is names, one on each line. And of course, it was the appending the +\n here that caused the new line. Okay, so it's just that easy to make that file. Now, let's say we want to read that file. Let's say we want to read them all. So we've got another program here called readpels. Take a look at it. Here's the file that's going to read all those names out of the file. This is called readpels. This time we're going to open the file called pals.txt again, but now we're going to open it in read mode. Notice the R, that's for read mode. We're going to hook it up again with an object called myfile. Now I don't have to call it myfile. I don't have to use the same name that I used when I created the file. I could use anything at all. I could change this here, but I have to change it in a few places, so I won't bother. Okay, so that opens the file in read mode now. Now, I don't necessarily know how many names are in that file. So what I'm going to do is after I print out a heading here are my best friends, I'm going to once again use a priming read to read a line out of the file. So I use the file object, my file, and the read line method. That will read one line out of the file and store it in a variable called pal. I need to do that priming read, before the loop starts so that I can use it in this expression here. And what that line means is continue to execute this loop as long as pal is not an empty string. Remember, this means that's the not equals to, right? So while pal is not an empty string, execute these lines here that are inside the loop. And if you look at the first line, what we want to do is we want to strip away that \n that's at the end of the line. Remember that we appended a \n onto each name as we wrote it to the file. Well, we want to take that out of there, because otherwise, if we try to print the pal, that \n would still be there, and it would cause a line feed at the end of the printing of the name. So we'll strip it out with rstrip. Rstrip, that means strip away from the right end of the string, which of course is the end of the string, strip away the \n. So what we'll do then is we'll print out the pal, and we'll print them all on one line separated by a space. But that just reads the first line of the file. We want to keep reading lines as long as there are lines to read. And so we have to have this continuation read, which is an exact copy of this line up here, the priming read. It's exactly the same. Read another line. And this will continue the cycle until it gets to the end of the file, in which case then this will be false, and that'll stop the loop. And you'll notice we're using the close function to close the file. It's always a good idea when you're working with files to make sure the file doesn't get corrupted, to close the file when you're through with it. So I'm going to give this a run. Let's see what happens here. Pressing the F5 function key. And there's the output that I got. And as you can see, it did print each and every one of the names that were on the file all on one line. If I hadn't put this line in here, watch what would happen. I'll comment this line out and run it again. See what it did? It did a line feed here, and then the space, a line feed and a space. So not quite the same. I want to get them all on the same line. So obviously I'd have to take the \n out to get them all on the same line. Okay, the \n is still there. You can't see it in the output, but it is actually there. So we just created a file, and then we just read the file. Open it in mode R. Any question about that one? Any questions at all, folks? No? No question about that one? Okay. You're a pretty quiet group.
Late.
Okay. All right, so I'm going to shut that down then, if you're okay with that. And by the way, this sort of stuff is covered in our textbook here. We've got chapter 6 open, as you can see in the ebook. But let's take a look at another one. Let's say we want to write some numbers to a file. Now, remember what I said at the start of this lesson. All of your input and output uses strings. So I can't actually write an int or a float to the file directly. I have to convert the int or float into a string with the str function before I can write it to a file. And we'll see that in this example. The next one here, I'm going to fire up. And what we'll do is we'll generate some random numbers. Okay, notice we're importing the random module as R. And this time we're going to open a file called nums.txt in write mode using the open function. And this time we're going to call the file object file. And here's one that in this case, it's a little bit different. We're going to ask the user in this case how many numbers are desired. So this time we're not going to use that while loop and the priming read concept. Instead, we're going to ask the user how many random numbers are desired, and then we'll run a loop that many times, generate a random number between 50 and 100 inclusive, and then we'll write that number to the file using our file object and the write function again. But notice, here's the key step right here. We have to convert that number, that integer, into a string before we can write it to the file. If I forget this step here, the program will crash. So this should write as many numbers as we want to the file. And at the end of it, of course, we'll get the file was created message, and then we should always close the file. So I'm going to give this a run. Here we go, the F5 key. And I'll say we want 12 numbers. Done. By the way, if I didn't put the file was created message in here, you wouldn't know that anything happened. So it's not a bad idea to put something at the end like that when you are creating a file. So apparently that created a file with 12 random numbers in it called nums.txt. Well, let's check that out. Yes, I do see it here in my folder. I'll open it up. And we do have 12 random numbers, all between 50 and 100, each on its own line. Notice we did the plus \n again so that we would get each on its own line. Every number on its own line. So it's just that easy to create a file with some random numbers in it. But remember, you cannot write the ints directly. I'm going to just wreck this, I guess, by taking that away. I'll just try to write the number to the file. Watch what happens when I run this. How many numbers are desired? Let's say I want 10. Boom, crashes right away. Unsupported for int and string. So we can't do it. It even identifies the line that's causing the problem. Okay, that's the line that's causing the problem. So I just destroyed that file. The file has nothing in it now, because when you go to W mode, remember, it immediately erases the file that's there called nums.txt and starts a new one. And since I crashed right away, I have an empty file right now. So what I'll do is I'll Control Z a few times to see if I can get back to where I was. And we'll just run that one more time to create our random numbers. And we'll go back to 12. Okay, so now I've got a new file with 12 random numbers in it. Just that easy to create a file. I could create a file with 1,000,000 numbers in it. It wouldn't take much longer. And that's the sort of thing that statisticians do when they want to do some stats with some random numbers. Okay, so now we've got that file. There are the random numbers I got this time. Now what we want to do is we want to read that file. So let's look at how we would read that. Well, we have an example for that. I've got one called read rands. Here it is. We're going to read the random numbers file. So notice this time we're opening the file in R mode for reading. And the file is called nums.txt. If I get any of that wrong, it's not going to work out. Now, here we go with here are the random numbers. And this time, I'm going to use the priming read again. I could have executed this by running a loop 12 times if I'd remembered that number. But what if I don't know how many numbers are in the file? Then I have to use this technique using the priming read concept. So I have to read a line out of the file. But remember, that line is a string. Now we know that there's a number there, but the number is inside quotes actually in the file. So what we'll do is we'll then use this while statement here to continue reading lines as long as we don't come up with an empty line. Then here's the key concept. If we want to convert that back into a number, we need to use the int function to convert the variable, the string variable, back into an int. just like we do with the input function, right? And then we'll print out the number, and we'll print them all in one line separated by a space. But then we have to use the continuation read here, which is, again, an exact copy of this priming read, to continue reading numbers as long as there are numbers there to read until we get to the end of the file. So we'll give this a run and see what we get for output. And there's the output we got. And of course, those are our numbers, 75, 60, 77, as you can see here. So that seems to be working. Okay. But what we're reading initially is a string. We have to convert it into the type that we want. For example, if I wanted to do some arithmetic with those numbers. And I didn't do very much, obviously, in this case, except read the numbers back from the file. But are you okay with understanding why that works the way it does? Any question about that, anybody? Feel free to ask a question. You can ask a question in the chat window, or you could turn on your mic and ask a question if you like. All right, not hearing any questions.
I'm good.
Okay, thank you. Okay, thank you for that feedback. All right, now I have another one that reads. Let's look at one more file that reads those numbers, but just does a little bit more with it. I'm going to read the numbers again, but maybe I want to do some work with them. I'm going to try adding them all up. So I'm going to create an accumulator with a value of 0 before the loop starts. And then I'm going to create two variables, odds and evens, and give them both a value of 0. I don't know if we've ever done anything like that before, but that's one way that you can assign a value of 0 to two different variables on one line. Instead of odds equals 0, and then on the next line, evens equals 0. That's a neat little trick that you can do in Python right there. Now, we're going to read the file like we did before. We're going to convert it into an int, but I want to add them up. So now I need to accumulate. So here's the accumulation going on, total plus equals num. But I also want to determine if each number is odd or even. So I'll use the num percent 2 equals 0. That, of course, is the test for even. And if that is true, I'm going to add 1 on to the evens counter. Counters go up by 1, right? Counters always increment by 1. Now, if it's not even, of course, it's odd, and we'll increment the odds variable. And then, once again, we have to have that continuation read to keep reading the numbers out of the file. And after the program finishes, we can then print some summary information, which we have down at the bottom of the screen here. We close the file, and then we can output the sum and how many evens and how many odds we found. So I'll give that a run. Let's see what kind of output we get from that. Here's the output we got. Just like before, I printed out the random numbers, and apparently they add up to 924. And it looks like we got 6 and 6, 6 evens and 6 odds. Let's see, there's odd, 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 odd. Yep, there's 6 odds, so there must be 6 evens. Okay, just showing you a little bit of what you can do with those numbers. We could have found the average. We know that there's 12 numbers, so I could have taken the sum, that total variable, and divided it by 12 to get the average number. We could do all kinds of arithmetic with the numbers that we've read from the file. Okay, any question about that one? Okay. Okay, well, we'll carry on then. And I just want to show you something that maybe a little bit more sophisticated and useful. Obviously, what we did there was just storing some names and storing some numbers is not terribly useful. What if we want to do something that's maybe a little bit more sophisticated? What if we, for example, did something like this? What if we wanted to keep track of the hours that we worked and the days that we worked? those hours? Well, we could do that very easily with a text file. We're going to record the daily hours here in a file called hours.txt. We're going to use W for the write mode initially. So that'll open up the file and make it available to us. It would also erase any file that already exists with that name. And then we're going to ask the user, how many days did you work? And then we'll run a loop that many times. And each time in the loop, we're going to ask the user for the day of the week, which of course is a string. So we use the input function. And then to get the hours that are worked on that day, we'll assume that they could work a partial number of hours. So we'll allow for decimals by making that a float. So we get two inputs from the user. Now we want to write both of those to a file. But I'm going to write each piece of data to its own line. In this case, we have two pieces of data, one for the day of the week and one for the number of hours that were worked in that day. But remember, we have to convert that float into a string before we can write it to the file. Once again, absolutely crucial that you cannot write an int or a float to a file. You have to convert it to a string with the str function. So I'm going to give this one a run. There's an example here. And let's say that I worked 4 days. And maybe on Monday, I worked 8 hours. Didn't work Tuesday, maybe Wednesday, I worked 10 hours. And on Thursday, I worked 8 hours again. Didn't work Friday, but on Saturday, I worked only 6 hours. Okay, so it did run 4 times, as you can see, because we indicated that we worked 4 days. So, and each time the loop cycled, we asked for the hours and the day of the week. So that's what's written to the file. Let's take a look at the file structure here. The file is called hours. I'll bring it up here. And as you can see, it does reflect what we entered, each on its own line. The day followed by the hours. And because we entered floats, you'll notice we got decimals in our input, but those were actually strings. We can't see it, but actually what's in that file is this. It's stored as a string. Unfortunately, it does not show up when we read the file. I'm going to have to save that because I was messing with the file. Just overwrite any change that I made there. Okay. Any question about how we did that? Now we have a file that's a little bit more useful. Now we can determine our total hours for the week. Let's try it. Let's try reading that file. So we'll just kill this one off here and this one. And we'll take a look at, I believe we have one here called pay file that we can take a look at. Yeah, take a look at this file here. Now what we're going to do is we're going to read the payroll file called hours.txt. We've got it in R mode. And this is going to be a summary of the hours. Now we want to add up the hours. So before we start our loop, we have to set an accumulator to 0. Accumulators are always initialized to 0. Now, we don't necessarily know how many days we worked. We might not remember how many days we worked. And so what we're going to do is use a priming read to read a line out of the file. And we'll continue to read lines as long as they exist. It'll continue to read, which is what this line means. Continue reading days out of the file as long as there are days to read. Now, we don't want to, when we print this out, we want to get rid of the \n that's at the end of the day. So we'll strip that away with \n. And then knowing what's in the file, see, we know the structure of the file, so we know that the next thing we have to read is a float. So what we can do is use file.readline, but the float method, and we'll embed the entire file.readline inside the float method, just like we do when we're doing the input of the float with the input function and float. So we'll convert it into hours as a float, and then we can add it onto the total. There's the accumulation where we can add up the hours. Then what we'll do is we'll print the day and the number of hours we worked on that day. And then here's the continuation loop, which is going to keep reading the file as long as there is anything there to read. Now, after we close it, we can print some summary information. We can total up the hours and print out the total. We could even then ask the user for their hourly pay rate, and we could determine their pay, including overtime if it applies. With this formula here, we could determine if overtime applies, and we could report the weekly pay. So now we have a pretty useful application that is reading our weekly hours and helping us with our pay to see if we're getting paid properly. So let's give this a run. Here's the output that the file creates. It's reading the file, and it's giving it's adding them up, shows the day of the week and the hours worked on that day, and the total is 32, which is correct, as you can see here. Now, that's not an overtime situation. Just to make the math easy, I'm going to assume that I make $10 an hour, and that, of course, would be $320 for the pay. So that appears to be working properly. I want to modify the file a little bit and add another day of the week. I'm going to modify the file. Now, I don't want to rerun the program and enter all of the days and hours again. So what I'll do is I'll just mess with the file itself if I can. And what I'll do is I'll add Sunday. I have to do this carefully or I can corrupt the file. And let's say I work 10 hours on Sunday. Now I'll save that. And now we'll run that program again. We'll run the weekly hours payroll program again. Here we go. Oh, could not convert string to float. Notice that didn't work properly because of the way I entered it. It didn't buy it. It did not buy this 10. So I am going to have to recreate that file. So I'm going to kill that off. I'll kill that one too, and we'll run the make file program again. Let's get it back up here. And here it is. So we'll run it one more time.
If you wanted to just add like one more day to it, couldn't you just do it in append? Or no?
Yes, I could have done that. I could have done an append. That's true. Not a bad idea. That would sort of mess things up about how many days and stuff, though. Well, I guess it could work with one more day, right? Yeah, that could work. I could change this to an append, and then in response to this question here, if I just want to add one more day, I'll just enter a 1, obviously, for that question. Yeah, we could do that. But I'll make the file all over again because I think I might have corrupted it there. So let's say that I worked 5 days. And on Monday, I worked 10 hours. I want to get myself into an overtime situation here. Tuesday, I worked 8 hours. Wednesday, I worked 10 hours. Didn't work Thursday. Friday, I worked 12 hours. And let's see, that's 1, 2, 3, 4. That's 5 days. That gets me into an overtime situation, I believe. So I'll go with Saturday. And let's say I worked 6 hours. Okay, so that created the file. Now let's run the other program again to calculate our pay. there we get the information back again. And as you can see, I've got 46 hours now. So I'm into an overtime situation. And once again, I'll try $10 just to make the math easy. And apparently that works out to $490 pay. It would actually be $40, 40 hours at $10 an hour. That would be $400, right? The so-called regular pay. And with 6 hours of overtime, I would get 6 hours at $15 an hour, time and a half on the 10. 6 times 15 is 90, so 400 plus 90, yeah, 490 is the correct answer for the pay. So that just shows you how you could work with files. Any question about this at all? Okay with it? Okay. I've got one more. Go ahead if you have a question.
No question.
Okay. I was going to show you one more example here. I have this file called grades, where what I've got is subjects and then grade scores. As you can see, we have it here for a number of subjects and scores. Well, let's say we wanted to read that file and display some information from that. Well, I shall leave it on the screen there so we can refer to it. And then look at a file that might read that file. Here it is. We're going to open up the file called grades.txt in read mode. Here's a summary of your grades. We'll just add a little bit of a title to the output. And what we're going to do is we're going to accumulate the grades, and we're also going to count how many subjects that we're going to read out of the file. Well, the first thing we have to do is read a line out of the file. Now, we know that when we created the file, it's subject grade, subject grade. Knowing that, we know that the first line in the file is a string, and so we need to strip away the \n. By the way, I guess I haven't mentioned it, but you do not have to take the \n. You don't have to strip any numbers. When you use the int or float function to convert the string into a number, the \n is lost automatically. Only a string can have a \n attached to it. So we strip away the \n from the subject name, then we read the score, convert it into an integer, add one on because we've now read one subject, and then we'll accumulate the score total by the value of the score. And then we'll print out the information for that subject. And then the continuation read to carry on reading as long as there is more subjects to read. And then at the bottom here, we're going to print out the average, which of course would be the total divided by the count. So let's give this a run and see what we get for the output. There's the output right there. You can sort of see everything on one screen here. Average is 85. This is just a wraparound. If you're wondering what the equal signs are, that's the end of this line up here. Okay. Now we could do other things. We could do some interesting stuff here. Like we could try to determine what's our favorite subject is, presuming that the subject that we got the highest score in would be our favorite. We could do that. What we could do is we could add some more code to this to determine what our favorite subject was. Any idea how we might do that? How could I determine, like obviously we know in the output we can see what the favorite is, but what if we wanted to detect that and print it out at the end in the summary at the bottom of the screen, at the bottom of the file? How could we do that? Well, what we could do is we could say high score is 0. Okay, what we can do is just assign an arbitrary value of 0 to a variable called high, which would represent the highest scoring subject, highest grade we have. Now, what we'll do after we read our values, right here, we could say if score is greater than high, well, then that's the new high. That's the new high. If the score is more than the high, then that is our new high score. And we could then say that our subject is the value of the subject variable. That's all we need. We don't need an else here. That's all we need. After the loop finishes, we could then report down here what the favorite subject was. So we could say, actually we can do it right here. We could say sub, not in caps though, sub is your best subject. And that should report the highest scoring subject. Let's check it out, see if that does work. Yeah, average is 85, but comp is the best subject, the one that we got 92 in. Okay, that's about it, folks. That's all I wanted to show you tonight. Any questions at all? Pretty straightforward. I did want to point out one thing though, and that is we do not have to do it, the exceptions part of the chapter. And that starts on page 324. So you can stop studying the chapter at page 324. Exceptions is not on the course. Okay, we're done. If you have no questions, I guess we're done. Everybody's good? Okay, Dexter?
I was gonna say, so the accumulator always, it starts out at 0.
That's right. If you want to add up some numbers, okay, I'm going to just start off. I'm going to ramble off a couple of small numbers. I want you to add them up, okay? Ready? Here we go. All right, I haven't started yet. What's the total right now?
0.
Ah, see, that's right. So you always have to start with 0 when you're adding up numbers, right? You accumulate. Now, if I say 3, now you know the total is 3. And if I say 5, now you know the total is 8, right?
Okay.
But initially, it's a 0. And counters are the same way. If you're counting something before you start, the count is 0. Yeah, you have to always initialize those to 0.
Okay, that's right.
All right, folks. If there's no more questions, I guess we're done. And we'll see you tomorrow.
Okay.
Thank you very much.